Hey guys, welcome to part 2 of 9.4 notes, which is all about graphing sine and cosine waves. This video is meant to be for Tuesday's notes, or portion of the notes and homework. Today we're focusing on kind of transformations of sinusoidal waves. So we've got some special names for them, but it's really just talking about how we would shift or translate our trig functions. And then the last piece is going to be putting it all together. So in part 1 of our notes, we went through just kind of the basics of how to graph sine and cosine waves. And then we worked on those, how we had basically stretches and shrinks. So how we deal with a change in my amplitude and a change in the period. So for this first part, we're going to be focusing just on shifts, so how we handle a vertical shift, which we call a displacement, and how we deal with a horizontal shift, which we call a phase shift or a phase change. And then for the second part, again, we're going to be putting it all together. So I'll go through some problems where it has all of the messy ugliness that you're going to have to deal with. So let's jump right in here. So with our vertical shift, which again we call displacement, all we're doing is taking a constant and adding it to my function. Now here again, where that addition happens determines whether it's a displacement or a phase shift because of where, whether it's a vertical change or a horizontal change. Just like with everything else, if I have an addition or subtraction happening on the outside of my function, that's going to be shifting my graph up or down. And all that's going to change is literally just taking that graph that we had graphed yesterday or for whatever other function I'm dealing with and just shifting it up. So now instead of starting at 0, I'm going to be starting at positive 2 in this case. Because the one that we're graphing here, sine of x, the original graph of this, starts at 0, goes up 1, back to 0, down 1, back to 0. Because I have a 1 for my amplitude, a 1 inside here for my b value, which means my period is still 2 pi. So for some of you, you might need to do this. I'll show you for this first one, and then for everything else, I'll just kind of be adjusting from there. If you have to graph the original first, just graph sine of x. You can go ahead and do that if that helps you. In this case, again, sine of x has an amplitude of 1, a period of 2 pi. So it's really shallow here because of how we scaled the graph. But that would be my sine wave. So if I'm just going to do a vertical displacement here, up 2, now I'm just shifting all of my points up 2 units. So that goes up 2, up 2, up 2, up 2, up 2. And you can see so close. There we go. Now that blue one is the only one that has to be there. And again, you don't have to necessarily do that process. I find it just as easy, or actually easier personally, that if that 2 is just telling me I'm shifting up 2, I would just go up 2, put my point right there. And then I know that since my amplitude is 1, I'm going to go up 1 from 2 up to 3, back down to 2, down 1 to positive 1, and then back up to 2 for my graph. And that's all a displacement is. That's all a vertical shift does. When we have an addition or subtraction happening on the inside, what that does is basically adjusts our interval starting point. It's still just going to be the starting point. I'm not going to adjust my phase at all, my period. That is still determined by whatever here is multiplied times x. So even though I'm adding pi over 2 on the inside, my period is still 2 pi units. So this one again, if you want to graph it out first, I'll do it in red to start with. My regular this is sine, yeah, so the regular sine of x is 0, up to 1, down to 0, down to negative 1, and then ends at 2 pi. a lovely sine wave. Now, with everything else that we've done, inside is opposite. So this is actually a shift pi over 2 to the left. Because it's inside, it is opposite. So if I see addition on the inside, that's actually telling me I'm moving pi over 2 units to the left. If I saw x minus pi over 2, that would be shifting it pi over 2 units to the right. So in this case, since I'm shifting it pi over 2 units to the left, I can really just take my graph, duplicate, shift it over here, so now it starts to the left pi over 2. I know you can't do those fancy steps. But now instead of starting at 0, it starts at negative pi over 2. My crest, it gets shifted over from pi over 2 to 0. My back to 0 from pi to pi over 2. 3 pi over 2 gets shifted to the left at pi. And then my end of my cycle gets shifted pi over 2 units to the left. Now they usually will do this if I have a phase shift or a phase change. It'll be using the interval units. So in this case you can see my interval for my regular cycle is pi over 2, because that's 2 pi divided by 4, pi over 2. Or maybe they would say shift it pi units to the left, so that it's still going to be nice whole shifts. So you're not going to have to deal with anything funky dunky where maybe it's shifting it to the left pi over 6, and then we still have these rotations that are happening. That's less common. Most of it we'll have to deal with as a displacement if we're shifting. I try to tend not to throw any kind of phase shifts at you. If you have those, it's going to be something like this, where you shouldn't be experiencing any problems where you have a period change and a phase shift. So 2 horizontal adjustments. So I try not to throw that much ugliness at you, but again, that's how we just handle it. So again, you can handle it 2 different ways. You can either graph the original like I did for these 2 and then just do the shifting afterwards, or you could just shift to where the starting point is and then graph the function as you normally would. So in that case, again, that's how I usually do it. In this case, you can see pi over 2 to the left just tells me that, I'm going to highlight here in orange, this would just be my starting point for my sine wave. And then everything else is still the same after that. So I'm still going to go up 1 since that's my amplitude, back to 0, down 1, and then I end back at 0. So that's how I would handle it. Okay. So as we continue down here, this next box is probably the most important one. This summarizes everything. It puts it all together. So what we talked about yesterday with my A and my B values for my sine and cosine, that changes my amplitude and my period. And then here we just threw in C and D, so we have letters A, B, C, and D for those individual shifts or those changes. Excuse me. So if you look here, the one thing important to note, again, if I do throw multiple different things at you where you do have a phase change and a phase shift, so we've got a change to my period and a change to the shift, like make it put a shift on basically. The important thing here to note is that if I have both of those happening, my B value is going to be written as a number outside a parenthesis. So you can see here I do actually throw it for this first example. Oh, I do actually for a couple of them here. You can see that this would be my B value and this would be that C value. That's going to be my phase shift. So I'm going to write it that way. If it's not written that way, if it was something like 2x minus 4 inside my sine, you have to be really careful with those, because that doesn't necessarily mean that 2 is your B value and 4 is your C value, because it has to be written as a parenthesis. So it actually would be written as sine of 2x minus 2, and even probably do brackets if I wanted to, kind of like I did for this first example. But that's how we'd have to have it situated. I don't usually have them that way. If I do have both of those things happening at the same time, it's going to be factored for you already. Just something to be aware of in case anyone sees those moving forward. Very unlikely in this class. So really what we're going to be doing is just kind of breaking it down and looking at all the different pieces. We identify everything first, and then we'll put it all together with my graph afterwards. So in my equation, I do like to try and label everything, label my A, B, C, D, and then I go to what that means for my problem. So here, my A value is 6. That tells me my amplitude is going to be 6. And we'll do the other two easy parts first. My phase shift, which is -11, right? Minus 11, so that means -11. Oh my goodness. I'm sorry, I'm not doing the same problem here. That's why it was so weird. Sorry, if you can see the time, it's almost like 1 o'clock in the morning on Sunday morning, because that's when my daughter is asleep, and that's when I can get some stuff done. So I apologize for the weirdness. This is two separate problems. Just this example, we're just identifying amplitude, period, phase shift, and displacement. And then we'll graph example number 8, which is a totally different equation. So for my amplitude, I'm just going to write it over here above it. My amplitude is 6, like we just talked about. My phase shift, -11, would actually be to the right 11, right? Because inside is opposite. My D value tells me my displacement. That's my vertical shift. So my displacement would be up 19. And then my period is the most difficult one, just because you have to do that division. My B value is pi over 12. So my period is 2 pi divided by pi over 12. So when I divide by pi over 12, that's the same thing as multiplying by the reciprocal of 12 over pi. My pi's cancel, and I get 24. So my period is 24. So then from there, if I was going to graph something like this, which is super ugly, if I was going to graph something like this, I would start by putting the start of my graph first. So what's usually 0, 0 would actually be 11, 19. So, because again, right 11, up 19, that's the start of my wave. My amplitude is 6, and my period is 24. So I would have here then that each interval, again, period divided by 4 is 6. So each interval is 6 units wide. My height of the wave is 6. So I'd go from 11, 19. I'd go up 6 and over 6. And then I'd go over 6 and down 6. Over 6 and down 6. Over 6 and up 6. But again, that's just how I would handle that one. For the last two that we actually have to graph, a little bit easier, a little more palatable. So looking at example number 8, my A value is 2. That's that very lead number. That's my amplitude. I don't have a horizontal shift at all because I don't have anything added or subtracted inside a parenthesis attached to my sign. So I actually have a horizontal shift of 0. And then that vertical shift of +3, again, happens not inside a parenthesis, so we assume it's on the outside. +3, which is up 3. Now, my period is always 2 pi divided by that B value, so 2 pi divided by 4 is a pi over 2. So this is another case where I don't like the scaling of my graph. I start at 0 and I end at pi over 2, which is good. But again, I want halfway between those two. That's going to be in this case, pi over 4. And then halfway between those, 2, 3, 4, and a little bit. So 1, 2, and a little bit would be like right here. And then we got 1, 2, and a little bit would be like right there. I'm gonna use my eraser to clean that up a little bit. So I've got actual dotted lines where I should have dotted lines. There we go, because that's something I care about at 1 o'clock in the morning. Yay! Anyway, so my intervals again, I take my period, I divide that by 4. So pi over 2 divided by 4 is pi over 8, which we did another one of those in part 1. So if you're confused on how I'm getting that, again, go ahead and rewatch part 1. That was in example number, scrolling. Where did we do that? Example number 2. I should kind of explain how to do that. Example number 2, all the way back in part 1. So, jumping back into the one that we're working on, now that we have that established, I still start with that first point. So, I'm dealing with sine for my function, which means it starts at rest, at 0. But in this case, my shifting that has happened tells me I'm shifting up 3. So now, the start of my wave is right there at positive 3. My amplitude is 2, so I'm going to be going from that point up 2 units during that interval. So here, which is, I forgot to label it, pi over 8, 2 pi over 8, which reduces to pi over 4, 3 pi over 8, which doesn't reduce, and then 4 pi over 8, which reduces to pi over 2. Anyway, so my amplitude is 2, so I'm going to be going up 2 units to positive 5, back down to rest, which is positive 3, down 2 units to 1, and then back to 0 at rest. Not back to 0, back to rest, which is back to 3. So it's the same looking graph, just shifted up 3 units, and has an amplitude of 3. Okay. Last one. Ooh, last notes problem of the school year? What? That's craziness. All right, last one, best one, right? So this, again, is one where I have it factored for you, and I do have both a period change and a phase shift, so we have to be careful with those. I have an A value, I have a B value, and I have a C value. I don't have a D value, which means my vertical displacement is going to be 0. It's still just centered at the origin, or centered at least at 0. My phase shift, I'm just going to work up my list now that I started down there at the bottom. My C value, which is in a parenthesis, and we have that coefficient of just x, that lead coefficient of 1, inside my parenthesis. So now I know that C value is my actual shift. So minus 3 tells me right 3 pi. Minus 3 pi is right 3 pi. My period is always 2 pi divided by b. So 2 pi divided by 2 would be pi. And my amplitude, which is that A value, is a positive 5. So now, the period, like the cycle that I'm graphing, starts at 3 pi and is pi units wide. So I know it starts at 3 pi because usually it starts at 0. If I'm shifting pi over 3 to the right, 3 pi right, that's right there when I drew my first dotted line. My period, which was right here, my period is pi units wide. So that means if that's 3 pi is the start of my wave, 4 pi would be the end of my wave. So it's been compressed a little bit. It's not as wide as it usually is. And actually here, this is how I usually set it up, where I just do 4 units in between, or maybe you want to space it out so it's a little bit more kind of accessible. these would be my intervals. So I'm actually going to erase all of that because I'm going to clean it up a little bit, but you can see each unit now in between is going to be an interval spacing wise. Delete that. I do have to label them. If that's 3 pi and then 4 pi, this would be halfway between those two, right? And then a quarter of the way in between those two. So basically pi over 2 is still, pi over 4 would be my intervals. So if I have 3 pi, which would, oh good lord, what's happening here? 3 pi, which if I do it in fourths, that's 12 pi over 4, right? Because if each unit is 4 pi, sorry, I'll write that out for you guys. So my period is pi. If I divide that by 4, that's how I get those intervals. So pi over 4 being my intervals. If I add pi over 4 to 3 pi, that's why I'm putting it in terms of pi over 4s. So 3 pi over 4 written in a common denominator of fourths would be 12 pi over 4. So this would be 13 pi over 4, 14 pi over 4, 15 pi over 4, and then 16 pi over 4. So you can see this first one, 12 pi over 4, reduces to just 3 pi. I don't know why it switched back to that. There we go. 16 pi over 4 is just 4 pi. This middle one reduces. 14 over 4 is the same thing as 7 over 2. So those would be my intervals. Not the nicest thing to do. And again, it's all just coming from my increments of my period divided by 4. So in this case, pi over 4. So now, all I need to do is put it all together. So I have my period labeled out. I have my intervals labeled. Now I just need to take into account my amplitude. This is a cosine wave, so it's going to start either at the crest or the trough. There is no reflection, so it's going to start up at positive 5, down to 0, down to negative 5, back to 0, up to positive 5. And again, this is going to be not the nicest thing because it's really, really steep. But that wave right there would be that graph. And again, here I have that note in here. Those two equations are not the same. Having 2x minus 3 pi instead of 2 times parenthesis x minus 3 pi, those are two very different things. This bottom one, this 2 would not be my b value. Well, it is my b value, but that means 3 pi is not my c value. Because what I'd have to do is factor it out, where I do just a GCF here, divide by 2, basically. So 3 pi over 2 would be that phase shift, which is super ugly, which is why I don't throw those at you very often, or at all. Okay. So your homework tonight, besides following along, or if you need to, go back and re-watch the stuff, slow it down, put it at 3/4 speed or half speed if you want to, so you can understand all the things that I'm saying. But really, as long as you have those 2, 3, 4 examples done with me, and you've been able to do that, or you've paused and followed along and kind of let yourself catch up, then your homework is just these last 4 problems in the worksheet, just page 10. So A, B, C, and D. And really, looking at those problems, D is the only one that's complicated. I mean, that right there is literally as complicated as it gets. It's got a reflection, it's got an amplitude change, it's got a B value that's going to change your period, it's got a phase shift, and it's got a displacement. So that right there, ugly, ugly problem. Take your time on that, label everything. That might be one where you do kind of that, what's the original one look like, and then do the shift, kind of like how we handled that horizontal shift. If you want to graph it to where you take into account the reflection, the phase shift, and the displacement, or you want to do maybe like the amplitude, reflection, and the period change, and then you just shift it after that, that might be one where that's going to be the most beneficial method for you rather than trying to do it all at once. The other stuff shouldn't be too bad. Really, A is just a vertical change, a vertical shift. B is just an amplitude change, shift it left or right. And then C is a shift both left or right and up or down. Okay. Once again, if you have any questions, please reach out and let me know. I know this is complicated stuff. I know it's not easy. I'm aware of that. This is always one of the worst, like these last two sections are the most complicated, most intricate, most difficult video or notes that we do, topics that we do. So please don't feel like you're dumb because you don't understand it, even if you've watched and rewatched the videos. This is something that just takes time to get used to. So reach out and let me know. If you're still confused, we can do a Google Meet. We can do, a phone call if that's easier for you. I can just type up some other tips and tricks to kind of clarify some stuff that you might be curious about or confused about. You just gotta let me know, okay? Hoping everyone's doing okay. Again, get all your stuff in. If you guys haven't heard yet or read the letter from Mr. H, May 20th is the deadline for everything that needs to get turned in. If you don't have 70% of your assignments for me done by May 20th, you are not going to get your credit for this semester. Okay? If you have questions on anything, could be the actual content here that we talked about today. It could be about grading and how things will be handled. Reach out and let me know. Hoping everyone's doing okay. I'll talk to you guys later.